Welcome to this video on AC servomotors prepared for the Census and Actuarial course at the National University of Colombia. In the next minutes, I will define what a servomotor is, how it works, give a review of its history and technical operations, and discuss some industrial applications and major brands. So, first of all, a servomotor is a closed-loop actuator that allows precise control of an output shaft or rotor position and speed. It combines a high-performance motor with a permanent magnet rotor and a feedback sensor, usually an optical encoder, with an electronic drive or amplifier. In essence, the servomotor plus its encoder and drive form a servo system that can finally adjust torque, speed, and position. Unlike a simple induction motor, a servo holds position even at zero speed, making it ideal for robotics, CNC machines, and automatic assembly lines. Now, taking a quick journey through the evolution of servomotors, I'll start by the mid-20th century, where DC servomotors were being used in radar systems and industrial machines. These relied on carbon brushes and simple voltage-based control, so they were effective, but they required frequent maintenance too. Then, in the 1970s and 80s, came a breakthrough: brushless DC motors with optical encoders. This removed the need for brushes, dramatically improving reliability and resolution. And well, finally, in the 1980s onward, industrial motion shifted to AC servo motors, where they combined permanent magnet rotors, three-phase stator, and powerful digital drivers with PED control. Today, this system dominates factory automation, powering everything from robotic arms to CNC machines, and integrated entirely with modern PLC platforms like Studio 5000 for Rockwell or the A Portal for Siemens. As you can see, AC servomotors are built like a high-end brushless motor. The three-phase stator winding produces a rotating magnetic field, and the rotor carries permanent magnet poles. In fact, an AC servomotor takes the three-phase stator control of an AC motor and the permanent magnet rotor of a brushless motor, yielding precise and powerful motion. The drive electronic servo amplifier constantly vary the current in the UVW stator coils to shape the field, and meanwhile, the encoder on the shaft tells the controller the rotor's actual position and speed. This creates the control loop. So, the drive uses PED control to compare desired versus actual position and adjust the torque or speed. Industrial servo drives typically have at least three nested loops: current, speed, and position, to ensure quick, accurate response. This tight feedback control is why servos can reach 100% torque instantly and maintain a stable position even under varying loads. Well, then in practice, AC servos are controlled by PLCs or dedicated motion controllers. For example, Rockwell Automation Studio 5000 Logics has motion axis instruction and electronic timing profiles for servos, while Siemens TEA Portal offers similar motion control function blocks and virtual gaming. Servo drives typically support modern networks. Most Allen Bradley from Rockwell drives communicate over Ethernet IP, while Siemens drives use Profinet. This let the PLC send motion commands and receive encoder feedback in real time. As a result, multiple servo access can be synchronized to follow complex trajectory. That is something precise for motion control. In short, AC servos integrate chainless into industrial automation, proving precise motion under PLC or other control supervision. So, with that, they are commonly used in CNC machines, robotics, baking lines, automotive assembly, like the robotic arm you are watching right now in the video, because servos are precise where dynamic motion is needed. As you can see, there are many servo manufacturers, for example Yaskawa with their SGM-AP series, or other major brands such as Panasonic with their Mina series, or Siemens with their, for example, Dynamic SB series, and also Rockwell Allen Bradley with their Kinetic series. So each brand offers a range of sizes and often has its own drive family for integration. So choosing a brand depends on performance, requirements, and compatibility, because established brands come with robust support but higher costs, while OEM units offer saving at some performance or support trade-off. Finally, major automation vendors offer servo products across a range of prices. For example, Yaskawa Sigma Sigen service is popular. A 1.5 kilowatts AC servo motor with its drive retail around 2,300 US dollars, roughly 10 million pesos. Similarly, an Allen Bradley Kinetics 5500 single axis servo drive can cost on the order of 24 to 4,800 US dollars, around 10 and 20 million pesos, depending on power rating. Also, a Siemens Dynamics V90 drive, 0.4 kilowatts model, is about $2,200. So at the low end, hobby servos and small kit drivers may be under $100, a few hundred thousand pesos, while high-end servo cabinets and multi-axis controller can run into 10,000 US dollars or more than 40 million pesos.